Hi and welcome. Today we'll be talking about this problem involving prime factorization and perfect squares. So first things first, we want to express 60 as a product of its prime factors. So that would be something not too difficult if you remember how to do it. So let's start with 60. What we do is divide it by the smallest prime number and until it cannot be divided anymore. So in this case, the first prime number, the smallest prime number is going to be 2. 60 divided by 2 is 30. Can we divide it by 2 again? Well, yeah. And this gives us 15. Next, can we divide 15 by 2? Well, no. So we move on to the next prime number, which in this case is going to be 3. And this is divisible by, this can be divided, this divides 15, so this gives you 5. And then just do it one more time. Nope, we cannot. So we are going to move on to the next prime number, which is 5. 5 divided by 5 is 1, and we end off over here. So these are all the prime factors. So we can just write it all together. So 60 is equals to 2 to the power of, in this case we have 2 2's, so we are going to have it squared, times 3 is to the power of 1, because there's only one 3, so we don't have to worry, and then times 5, again to the power of 1, so we don't have to worry. Okay, this is part 1 done. Next, we want to find the smallest positive integer k such that 60k is a perfect square. Now, let's recall some properties of a perfect square. Let's say that we have, let's say maybe 16. 16 is a perfect square because it's 4 squared. If you take a look at its prime factors, it's 2 to the power of 4. Notice that 4 is an even number. 36 is also a perfect square because it's 6 squared. And if you look at its prime factors, it's 2 to the power of 2 times 3 to the power of 2. It's 4 times 9, which is 36. Again, its powers are also even numbers. So, in that sense, what we want to do is we want to multiply a number k such that this number has all powers to be even numbers. Notice that we are taking 60 times k, which means that we cannot divide. So, let's visualize this a little bit. We have 60, which is 2 to the power of 2 times 3 times 5, which we can represent using blocks. So we have one block of 2 times 2, another block times 2. We have one block times 3, and one last block times 5. What we want to do is put in additional blocks such that the number of blocks in each tower is going to be an even number. As you can see, we have 2 blocks over here, which is already an even number. So we don't actually have to we don't have to put in additional blocks. Because we could, but we want the smallest positive integer k. So we are not going to be putting additional red blocks. This tower only has 1 block. So we need to put in an additional times 3. And this tower right here is only one block tall. So we are going to need to put in an additional block of times 5. These 2 blocks that we have put in additionally will be our number k, which is just going to be 3 times 5, which is equal to 15. Let's take a look at 15 times 60. So let's just do that real quick. I'll just add a 0. That's 36, 79, 900. It's equal to 30 squared. So this is indeed a square number. So yeah, that's pretty much all I have. Thank you so much for watching, and I'll see you guys next time.